Hello, my name is Professor Johnson, and today I'm going to show you a tree diagram example without replacement. So in this example, imagine you have a deck of 52 cards, just a standard deck of cards. We take the jokers away. So you can see we have king through ace and we have 4 suits. Now we'll draw a card from the deck, and then without replacing that card, so we'll keep that card, we'll draw a second card from the deck. So we're drawing 2 cards total, one right after each other, but we do not put one of them back. Well, we don't put any of them back, actually. And then we're interested in the probability of drawing 2 face cards. So getting a face card drawn first and then also second. Okay, represent the situation with a tree diagram. Now, face cards. Okay, so face cards, I'm going to use F for face card. And then everything else, you see there's King, Queen, Jack, those are face cards. Everything else is just a number card. So I'll use F for face cards. And then I'll use N for any of the number cards. Okay, so we have face cards and number cards. Now, with the face cards, you see how there's 3 King, Queen, Jack. There's 3 of them, but there's 4 suits. So 3 times 4, really in the total deck, there's 12. And then over here, there's 10 through ace. That's really 10 times 4 gives you 40. And if you add those together, that gives you a total of 52 cards. So you can see we've accounted for all of the cards. Either going to have face cards or number cards. So let's make our tree diagram. So we'll have F and then N. And then we also have F and N, face card, number card. Now, the first branch that I created right here, this represents the first drawing. So we're drawing here first, and then this second grouping of branches is the second draw. And I'm going to place the probabilities on each of these tree branches, which is why it's called a tree diagram. Now, if we look at the first branch right here, just our first branch right here, what I put in red. Okay, drawing a face card. What's the probability of drawing a face card? Now, we know there's a total of 52 cards, and we would have 12 face cards out of 52. So 12 out of 52 is the probability there. Okay, now if I go over here to the number cards, we know that there's still total out of 52, but picking a number card, that probability is 40 out of 52. Now you could reduce those fractions if you want, but I'm going to keep it this way so you can see that if you add those two together, the 12 over 52 and the 40 over 52, that adds up to a probability of 1. Okay. Now I want to continue on to the second draw. Now in our situation, we have without replacement, right? So we're not putting the card back in the deck. So if we take the card out, how many cards are remaining? There's not 52 remaining, it's really 51 remaining. So for every single one of these probabilities, it's just out of 51 because we did not put that card back. Okay, let's go down this first branch, the very first one right over here. If I go to here, now imagine we're following the branch, so the red branch, you have 12 out of 52. Now, if you picked a face card first, really, there's only 11 face cards remaining. So it's 11 out of 51. So you're picking a face card first in the first draw. That means you only have 11 out of 51 for your chance to get a face card in the second draw. Now, if you go to here for the number cards, really, if you picked a face card first, there's still 40 number cards. Okay? So you haven't touched a number card yet. But if you go over to the right-hand branch, that over here with our number card, now if you picked a number card first, there's still 12 face cards remaining, right? Because you picked a number card first and you kept it, going down that branch, there's 12 face cards remaining. And then going down this, the number card, if you picked a number card, now there's only 39 number cards So 39 out of 51 is the probability there. Now, what's neat with these tree diagrams is we can find probabilities relatively quickly. And we do that by multiplication. Now, our probability that we're asked is drawing 2 face cards. Okay, so we want face cards. So what that tells us is go to the face card branch, this tree, right? We follow this branch, the 11 out of 51 and the 12 out of 52. All you have to do is multiply them. If you multiply 12 over 52 times 11 over 51, we will get our probability. So let me multiply that out. If you take your calculator, make sure you put parentheses around your fractions, and if you reduce the fraction, you'd end up with 11 out of 221, which is approximately 0.4977. So approximately that. Not a real nice number, but that is our probability. We know that's a valid probability because it's between 0 and 1. Now you can do this with any of the other ones as well. You could find number card. You could find face card or number card, but with face card or number card, you have 2 branches to account for, so you add them together. So let's continue with this example by finding the probability of drawing a face card and a number card in either order. So that's those middle 2 branches I was just discussing, right? These 2 middle ones. I'll highlight them in blue. So face card to number card, or number card to face card, either order, right? Either order. So we want to multiply, and we'll go down the first branch, 12 out of 52, multiplied by the number card branch there, 40 out of 51, and we have to add it because it could be either one, either order, 40 out of 52, multiplied by 12 out of 51. Okay, then we can take out our calculator and use parentheses and multiply 12 out of 52 times 40 out of 51, and then use addition, 40 out of 52 times 12 out of 51, enter, and you get approximately this. But if I want the reduced fraction, I can always hit the math button, fraction, enter, and that'll give you 80 out of 221. And that will be our final solution. Thank you for watching my video.